So for the next panel, Going Electric, I'd like to invite the participants to the stage. So we have Eduardo from Hart, Sebastian from Vidiian, Roberto from Voltero, and Hedris from EASA. And the format here is everybody will have 10 minutes, and I'd ask you as far as possible to try and respect those 10 minutes, and at the end we'll have a common question session. Okay. So actually, Eduardo, if you could start.
Sure, take the stage.
Yeah, then please go ahead.
All right, good afternoon, everyone. Thank you all for your time. Thank you for the colleagues of this panel, and a special thanks for EASA for allowing us to discuss those subjects that are so dear to all of us. My name is Eduardo Meyrink. I'm the project certification manager of the ES30 project in Hart Aerospace. And I'm here to talk a little bit on the certification challenges of a CS25 electric hybrid aircraft. And before that, I would like to talk a little bit on how our company and our product have evolved to what we have today. And first, a little bit on us. Hart Aerospace is a startup company based in Gothenburg, southwest of Sweden. It was founded in 2019 when a few people joined and believed in the vision of our founder and CEO, Anders Forslund, to develop a full electric 19-seater passenger aircraft. Today, we're about 200 people from more than 30 countries, and we have already circa more than 400 commitments between orders and letters of intent from operators and leasing companies of 3 continents. In terms of the product, in a nutshell, the ES30 is a hybrid electric aircraft to be designed and built in Sweden to address mainly the pillars of lower emissions, lower operating costs, and to better connectivity for underserved airports. But in fact, in terms of our journey, the journey of the product, we actually did not start with the ES30, as you have seen in the previous slide. We actually started with the ES19. Back in 2019, we saw the need to develop an aircraft to address some market constraints from the Nordic countries, where some of those were put in place mandates for zero-emission operations up from certain dates. And at the time, the ES19 was conceived to address that niche market. It was a 19-seater aircraft, full electric, to be certified under CS23. However, as we started or continued the development of the product, we started to gather interest from operators in places other than the Nordic countries. And with that, we started to have some product requirements that were not initially in place. For example, as we needed to bring more passengers on board, it was difficult to adhere to the CS23 maximum passenger capacity and maximum takeoff weight limits. Also, regarding the operating restrictions, particularly in the United States, the Part 121 restricts the operations of CS23 aircraft certified from a certain date. And also, still on the operational rules, particularly those related to fuel and alternate airport rules. The performance of the ES19, as it was before, started to be compromised in order to adhere to those constraints that we had under the CS23. And with that, we came to the ES30 as it is today. It's a hybrid electric aircraft, but still capable of full electric operations, with a maximum passenger capacity of 30 pax, and to be certified under the CS25. With that came some challenges that were already before, regardless of the CS23 or the CS25. but also some of those came into place when we transitioned from this certification basis revised. For example, the regulatory framework is still under development, and this is a particularity for the CS25. We are one of the first applicants for a clean sheet CS25 aircraft, whereas for eVTOLs and CS23, there are already other players in the market. And as a result of that, the changes to those regulations, particularly the CS eVTOL and the CS23 and even the special condition E19 for the electric hybrid propulsion systems, those changes have not yet made their way into the CS25, particularly that transition from being design constraint versus performance-based. Regarding the means of compliance for novel technologies, yes, they have yet to be developed. As a few examples, even when the regulations are already in place, they need to be developed to address those new or novel technologies. As a few examples, we can name the electric hybrid propulsion systems themselves, where the special condition E19 is in place. However, the means of compliance, they need to be developed to be tailored to the specific aircraft application. We also have, as another example, some considerations on the high voltage storage and distribution, where that delineation between low voltage and high voltage is yet to be better understood, I would say, by the industry as a whole. And we also have aspects of those high voltage running through the aircraft, and also aspects related to the component qualification and standards and so on and so forth. On the propulsion battery considerations themselves, of course, yes, we have regulations and standards that are applicable to batteries, but they were not conceived initially to address the energy levels of that we have now for the propulsion batteries. And therefore, some new considerations have to be put in place. As a few examples of what I would have, aspects related to survivability, crashworthiness, intrusion to the passenger cabin, flammability aspects, fire protection, and so on. Yes. And another one that has already been discussed a few times today are the aspects of the international harmonization on the regulatory framework, on the product regulations themselves, and also on the product and qualification standards for specific aspects. Knowing that the longer it takes on those aspects, I would say the higher is the risk that we are bringing into our product development in case those differences are known, I would say, too late in throughout the product development. And that's why I was so glad to hear that those developments and progress on the task-specific teams are progressing well. And particularly on our side, we have to do all that being a startup company. So at the same time that we're building a product, we're building a company, as several of the participants here. So we have all of those aspects related to the company culture, values, bringing in people that believe in that vision. And we also have this responsibility of building on the legacy of safety already established by consolidated OEMs and why not the whole aviation ecosystem, authorities, operators, maintenance organizations, and so on. We know that flying is the safest mode of transportation, and I guess that some of the newcomers or who are bringing those new technologies and new products to the market, we have to live up to this, I would say, safety legacy that has already been developed by the rest of the industry. And as already mentioned by one of the few participants here earlier today, working together is the best way that we can get this done. So thank you very much.
Thank you very much. Thank you very much, Eduardo. Then we move straight on to Sebastian, please.
So, hello as well from my side. Let me introduce myself. My name is Sebastian Seemann. I'm the technical lead, call it CTO, and one of the two co-founders of Vidiian. I'm representing Vidiian is call it an OEM. The company is an SME, call it a startup, if you like, with the ambition to develop, to certify, and also to manufacture a fully battery electric 9-seater commercial commuter airplane. And in that context, I'm really feeling honored having the possibility and the opportunity of sharing with you our view and also our status on certification with a particular focus on regional air mobility. So certification comes first, not last. We're in a completely new field of aviation with a lot of players, many more players, and different nature of companies than we were used to in the last decades. And in that, we tend to underestimate and delay the efforts, particularly related to certification. I can tell you a story of Vidiian. 2 years ago, when we only existed on paper, my co-founder and I, we traveled through the lands and were looking for some funding. There was no budget yet, there was no team yet. The very first thing that we got to paper was a very, very small contract, a subcontract, to engage with an external DOA. Not to become a DOA ourselves, but to cooperate with the DOA in order to prepare our engagement for the both topics, for certifiability of the aircraft, but also for communication with EASA. And only 3 weeks later, we bought our first PC. That was exactly the first thing we did as a company. Looking at certification approaches in regional air mobility, you could simplify it to 3 approaches. One of them is retrofitting an airplane. One of them is building something from scratch, which is extremely complicated. And one of them is somewhere in the middle. Retrofitting an airplane is, I think, an engineer's dream. So you have something that is already available and you build an electric propulsion system in it. And ideally, you get away with an STC, probably with minor changes. However, the big question remains on the market side. Is it going to be an economically interesting product? Does it have range? Does it have payload? On the other side, I think every one of you has many projects in mind that just start combining just a few too many risks, as maybe being a very young company, maybe having a very complicated system, maybe having like the infrastructure lacking. All of this can be done, but what we have decided for our case, for Vidiian, is it has to be simple, it has to be in line with what is certifiable, and it also has to have a performance that provides some economic viability. And why do I say that? Not because the other projects are worse, or I need to be right, I don't need to be right. But we together, we want to get something forward. We want to get sustainability really leaving an impact. And leaving an impact means these aircraft need to get certified. They need to get on the runway. So they need to get into operation as densely as possible to actually leave that positive impact. So we believe it has to be the optimal match between certifiability and economical viability to be a successful project. Who is Vidiian? Vidiian is very much a technology team for the moment. So you will see around about 20 persons on that slide. None of these persons have the same capabilities, very, very different skills. All of us are technically very experienced in the average of 10 years professional experience. I can share with you one particular detail is one of the first persons we hired was actually for hiring. So an HR person. And that very much contributed to the success of the very first year of the company, completing this technology team. And you will see again that the first phase is really about focusing on the technology, but we're currently also already preparing for the next phase, which is entering into an aircraft development program, having hired our VP engineering, kicking off the next phase. The aircraft is a very conventional aircraft, and it looks very much like a glider. It's a motorized glider, if you like. It's going to transport 9 passengers over a range of up to 500 kilometers, nominal distance between 2 airports, IFR, commercial IFR, flying in IMC conditions, flight into non-icing. It operates from existing airports. It is really designed for the highest possible energy efficiency, knowing that we fly with batteries. Batteries will always be a level lower, a factor lower than hydrocarbons in terms of energy efficiency. We know that. So we need to optimize the knobs we can optimize. We have exactly 2 certification challenges from our perspective. One of them is building a safe battery and integrating it in the wing. And the second is building and developing a completely novel propulsion architecture, because what you see is a single propeller, but what it is a multi-engine aircraft to be able to fly IFR. And this is something that is a little bit different than the approaches you may know when it comes to electric aviation, which is not distributed propulsion because we can do it, but which is, you could call it concentrated propulsion, because this also now is possible, stacking electric engines, if you do it in a smart way, on the very same mechanical output. Our approach, our project is very much objective-driven. It has to be a commercial airplane. It has to manage risks. It has to be successful in the market. It has to be low cost as it can be. And we need to kind of manage it as a startup, really being a new company. And that's why we decided, okay, let's limit the number of seats. Let's not go to the upper end. Let's try and get it as a single pilot aircraft, which you can do up to 9 seats, and ideally build it and develop it as a non-complex aircraft. And that very much defines for us the certification requirements we are following. We're not sitting there by coincidence. We have deliberately decided why we want to be exactly at that spot. The phase we're in right now is the technology phase. But with this de-risking approach of having an established infrastructure, having a very conventional aircraft, having technology when it comes to batteries that is actually existing from suppliers, and also with a very much defined certification framework, we believe that certification of that aircraft is very well possible before the end of the decade. And this is, of course, as well our ambition to motivate ourselves and to motivate the people that we drag along, our partners, our suppliers. We are now demonstrating these 2 key technologies that I was demonstrating, but we are also engaging with EASA, and we are all integrating everything into the overarching overall aircraft design. And right now, we are putting together a baseline which tells us that this is going to work if we get it done. Very important for this phase that we are currently in is certification. So we engage with EASA already in that phase by means of talking about the pre-application services that were also emphasized a few times before. We couldn't afford, being a startup, only handing in a TC application maybe in 2025 and then executing for 3 years and maybe extended a little bit, but only learning at that point in time that some key elements of our certification basis are actually not going to work out. So we believe for startups, for this new, say, ecosystem of very innovative companies, the services now offered by EASA are actually ideal to grab. So we've tried to be selected as one of these companies, and I can gladly report that we have done a pre-application meeting in June this year, which was extremely positive. I would have wanted to conclude on this presentation by saying that we have actually signed the pre-application contract, which hasn't happened, obviously, so I need to change my ending into being very, very positive that before the end of the year, this year, 2023, we will be starting in an actual contractual collaboration on the topic of certifiability with EASA. Looking forward to your questions, and thank you very much.
Thank you. Yeah, Roberto.
Good afternoon, ladies and gentlemen. First of all, let me thank you, the organization of this conference, for inviting Voltero and giving me the opportunity to make this presentation. My name is Roberto Iannuzzi, and I'm the head of airworthiness in Voltero. Voltero, even if it's a new company that was founded in 2017 and is based in Nouvelle-Aquitaine region in France, has been founded by people that come from Airbus experience industry. And in that period, these guys has experienced, acquired a lot of knowledge about electrical propulsion through the Electric Cricri project, the EFAN project, and then when they started with Voltero company, they opened the door to hybrid propulsion systems, and they transformed the Skymaster aircraft, Cessna 337 aircraft, to install a hybrid propulsion unit of 600 kilowatt. Today, this platform, this experimental demonstrator is flying also with using SAF bioethanol fuel, as we fly on 7th of September. In a parallel way, the company started a project for Casio family, a CS23 category of a product named the 330, 480, and 600. The number represented the power installed in kilowatt. All of them are hybrid propulsor. Today, we are in progress with type certification of the 330 model. We have in phase 2 certification. We have presented the full mock-up, the full-scale mock-up in June at Paris Le Bourget Air Show, and in August at Oshkosh Air Venture. Our plan is to get the type certification in 2026, and after that, we will start with the 480 model and the 600. But now, let me focus mainly on some certification highlights regarding the Casio 330. I have represented in a very schematic way the certification basis of the aircraft that is mainly based on Amendment 5 of CS23, of course. The aircraft is a normal category, level 2, with 5 seats, maximum takeoff weight less than 2 tons, fixed landing gear, and with the pusher propeller. The other pillar of the certification basis is the special condition in 19 that cover, of course, the HPU requirements and its integration on the airframe. Today, we are fully involved in the definition of the means of compliance and method of compliance that will be presented in the next weeks to the EASA team. And, okay. I will focus mainly on two kinds of subjects. The first one I have called challenges, and the second one I have called the discussion point. Challenges are mainly related to design aspect that for novelties in conjunction with the new regulation may represent a very high criticality in terms of development, in terms of acknowledgement, in terms of time, in terms of cost, and they are mainly the HPU, the high voltage propulsion battery, and also the operational aspects. For discussion point, I mean some lower criticality topics that are more related to more conventional aspect, and sometimes there are the consensus standard and the acceptable means of compliance provided that are available, sometimes need to be discussed and clarified with the team. Let me share with you some example. Regarding the biggest one in terms of challenges, of course, the HPU, that for our application is made by a thermal engine from motorbike application to be certified as a part of the aircraft. So this is the first big problem. The electrical engine that fortunately is provided with own type certificate by Safran. The gearbox that couple in a parallel way these two power sources. And the heart of the system is made by the HP management unit. It is a really black box made by hardware by software, developed by us with support of some suppliers. that is interfaced with the pilot through a single power control level plus a selector of hybrid modes, and provide to the crew the display on the avionics display, the power plant parameters and the CAS messages. Regarding operational rules, we have discussed with the team about the use of the aircraft as a single engine, and this topic has been treated in a dedicated certification action item that we have discussed. We have agreed in terms of contents, and we expect to go in flight to verify and validate our hypotheses and our assumptions. The approach we are following for the HPU development and certification is mainly based on safety analysis. It is based on standard guidelines from ASTM and SAA, both at aircraft level and system level. We have identified a test matrix following a build-up approach, starting from a bench test on the single components, sub-components, integrated subsystem and whole system, and then finally with the integration of the whole system on the aircraft. To following a de-risking approach, we will start first with a dedicated prototype by flying only with the thermal engine in order to better investigate and to understand the behavior of the most new parts, most novel parts of our project that are the Kawasaki engine and the gearbox, other than the experimentation of aerodynamical behavior of the three surfaces aircraft. After that, we fully integrate the HPU units in another dedicated prototype that we will use for demonstration of compliance for type certification. The second big challenge is related to the high voltage batteries. If you imagine that we are more than 200 kilos of high voltage battery under the floor in the belly part of the fuselage, you can imagine that a problem like thermal runway, disconnection, structural protection, venting, draining, are very, very hot topics. And today, we know that some regulation in terms of means of compliance are in development. We are referring to what we have available today that's related to VTOL, DO311A, and other guidelines. And our approach is to find the best compromise between prevention and containment at various levels, from the cell battery up to the integration on the aircraft. Regarding discussion points, my example are very few, because I focused on some topics that are related to the definition of limit engine torque by the regulation, where both ASTM and CS23 Amendment 4 provided the same information, the same indication in terms of load coefficient, doesn't take into account the hybrid propulsion scenario. This is not a real critical topic, of course, but will be discussed with the panel expert in order to identify the more appropriate approach for the definition of load for gearbox dimensioning and engine mounts sizing. Another tricky aspect is related to the installation of fire protection. Since the installation of the HPU is on the aft part of the fuselage of the aircraft, the ASTM prescribes for all the aircraft the existence of a fire extinguishing system. On the contrary, the Amendment 4 is more easy to approach because it requires this kind of requirement also only for commuter. For us, the introduction of such system is not easy, and I suppose that will be a discussion point to face with the panel 7 at 4, probably also with an inter-panel discussion with the team. In the end, another example is related to the assumption for flight load calculation. Neither CS23 nor ASTM mention the three surfaces configuration in the definition of loads requirements, but only Canard the tandem wing. We know that historically there is another big project, the P180, that have been developed with this, certified with this configuration, and we expect also for us to discuss this point with the panel 3 expert, and probably will be a special condition or something like that. To conclude, it seems that today the leitmotif is more related to novelties, and the problem addressed to the Voltero as an aircraft manufacturer is the challenges that the novelties introduce in terms of knowledgement, in terms of skill, in terms of time, in terms of cost. For sure, if the push works, okay. For sure, the no more perspective regulation provide the right flexibility to introduce such kind of novelties in the new generation project. But on the contrary, we still have some points that are not straightforward in terms of identification of the most appropriate means of compliance. And we know that the consensus standard is still in development in order to improve and to cover some aspects that historically are covered by special conditions. And in conclusion, what I have to say, that today the leitmotif is the cooperation, the discussion, the open discussion with the agency. Because today, in front of such novelties and such technologies, the goal is common between the companies and between the agency. So having a good relationship and the trust with EASA is really a paramount. And that's all from my side. Thank you for your attention.
Thank you, Rodolfo. And then finally, Hedries.
Good afternoon, everyone. My name is Erdre Sarzan, and I'm section manager for General Aviation and VTOL in the propulsion domain, and also it addresses also the integration, so the power plant aspects. I'm going to do this presentation seen from the regulator perspective on EHPS. So there is today, yes, a range of technology required in order to meet aviation industry decarbonization ambition, and electric and hybrid propulsion system is rapidly revolutionizing mobility technology across industries, starting from the automotive industry, and aviation is no exception. And at EASA, we developed the regulatory framework for aviation industry, adopting alternative propulsion system and also new propulsion technology. Those innovative propulsions create several opportunities, and also they come across with a new dynamic, starting in the general aviation domain and expanding quite quickly towards the large aircraft domain. It creates opportunities for also new aviation products, such as the eVTOL, to foster urban air mobility. Innovative propulsion is also bringing new challenges, new interfaces, new interaction, new functions, and also new design organizations. And it's a challenge for EASA and industry. So this shift in aviation is fairly motivated by the European Union subsidies having mid-term 2035 and long-term 2050 objectives for sustainability. And our industry has to face this major challenge collectively with engine manufacturers by proposing various architectures, rendering the existing requirement not fully adequate. So we need to adapt our requirements. They are considered too prescriptive. So the solution found was to develop performance-based requirements. We decided to develop a set of special conditions for the lower boundary of airplane up to the higher. But the key element of this strategy is also to rely on standards, industry standard in particular, while keeping an acceptable level of safety. The last born of this series of special conditions is a SCE19 that has been mentioned several times during this forum. It was published in April 2021. It's a performance-based requirement dedicated to electric and hybrid propulsion system, and it's associated to the aircraft application. This special condition is associated to the aircraft application because it's important to be consistent with the aircraft certification requirement and also enable an integration of the propulsion system within the aircraft. The special condition can be used as a basis for certification of an engine alone or used in an aircraft certification as a special condition. So it's applicable to CS23, level 2 and up, namely 27, 29, eVTOL, but also CS25. So between the performance-based requirement and standards, we found necessary to develop means of compliance. Why? Because industry need guidance to secure their design, as it was said previously. Also, standardization group needs to be confident in their priorities. So we have run at EASA, excuse me, I just, it was not the right style. Yes. So yes, we have run at EASA a gap analysis allowing to identify what are the existing requirements, what we need to develop. And therefore, we could identify a set of means of compliance defined as a priority that we needed to develop, and we have decided to adopt a 3-level approach with level 1 and level 2 and level 3 MOCs. So every applicant in the future will be able to go to EASA website and select their design specificities, and they will get as an outcome a set of comprehensive requirements composed of level 2 and level 3 guidance. The level 2 guidance will be very similar to what we have today in book 2 of the CSs. The level 3 guidance will be more method of compliance, so standards, guidance material, certification memos. So the level 2 will either provide direct guidance or explain how level 3 document should be used as acceptable means of compliance. So this is an approach today that we have adopted, and we will keep working with authorities and industry to develop such guidance. We will work with a standardization group to identify priorities and work in a simultaneous manner. And when the means of compliance will be drafted and mature, we will exchange also with industries. So now, having developed a lot of elements, we need to make sure that we are in line with our bilateral partners. And today, when an applicant is actually applying at EASA for a TC, usually together with this application or shortly after, they apply for validation. And it's important to ensure that our rules are well recognized by our bilateral partners. And if we take the example of the FAA in here, we have different references in terms of rules. So we have a special condition, they have the Part 33, and they complement Part 33 with project issue papers, because they cannot adopt simply a special condition. It doesn't exist in their legal basis. So where we can actually work together is on the MOC. We can develop similar MOC, because at the end, the rule intent is exactly the same, although the content is not identical. So we will work on the same MOCs in order to help industry in the harmonization effort. We will also make sure that we will rely strongly on standards. The objective is to recognize common standards or to have mutual recognition of the standards developed by both parties. I want to mention also that there is a wide work that is performed today in the context of the certification management team. It was mentioned previously by Mario. And so Transport Canada, FAA, EASA, and ANAC are working together on the task force. The objective is to discuss and find solutions for topics that require harmonization. They have started to work on several topics, and I hope it will allow to answer to a previously raised question on the CMT task and deliverables. So in the target is the definition of safety objectives for electric engine, but also the definition of loss of power control. There is also items relevant to the battery integration and interface with the engine and also the aircraft. The first deliverable has been submitted for acceptance early this week, and you will probably see coming out a document with some elements to justify loss of power control for level 1 and level 2 aircraft very soon. If you want some information on the deliverables, there was a webinar that took place some time ago in April, launched by Régis Rossotto, who is our EHPS expert, a senior expert now. And over there is listed all the deliverables. So as a conclusion takeaway from this presentation, I think we wanted to communicate to you that work on the HPS MOCs is in progress. We really encourage industry to collaborate also with us and among each other in the standardization group. Every new applicant should join standardization groups as soon as possible to have their design represented. Also, we would like to pass a few messages regarding the coordination between standardization group, in particular EUROCAE and SAA. They should work together and maybe work on complementary standards in order not to avoid to duplicate effort and to stay consistent overall in the strategy. And I would like to finish by saying that at the end, safety is our common goal, so we have to work together on that. So I would like to come back on the causality dilemma between the technology and the rule, best known as the chicken and egg question, what comes first? It was shown in a previous conference, I reuse it. And I took advantage of this morning breakfast with my daughter to ask her, okay, what comes first, the chicken or the egg? And she answered to me, the dinosaurs, Mom, obviously. So she was probably not referring to the technology, and this reflects on me. And I thought that this future user of eVTOL probably anticipated that we as EASA, we have to stay in pace with industry and to adapt our rule accordingly. So in my opinion, the answer is that it's not that relevant as long as we work together to build guidance for the future and foster sustainability. Last but not least, I would like to communicate that we will run a webinar on the 13th of December. It's a new date. We have changed the date. This will be an opportunity for our technical team to present to you the work performed so far with more technical details. And amongst others, you will have information on the CMT tasks. You have to register either to a morning session or an afternoon session to receive the WebEx link. So it's free of charge, so you're welcome to join. Thank you.
So thank you very much, Idriss. I think you'll all agree that there was 3 very interesting projects there and a very interesting presentation also there, Idriss. So now if we go to the questions. So the first one, how does CS25 regulate the thermal runaway of propulsion battery system?
I can try to answer this one.
Yeah. Yeah.
So basically today the plan is to use the same guidance as a special condition VTOL, the MOC3 that was mentioned previously, to treat CS25 regulation in terms of thermal runaway.
Okay, thank you. The next question: how is the availability of certifiable components related to engine control and battery management for electrical propulsion? Shall we start, Eduardo? Can you say anything on that from your experience? Or?
Yeah, sure. well, as in any new developments, we have things that are already available in the market. So that it's, I would not necessarily say plug and play, but we can see that the fundamentals are there and they comply with what is expected. But for some of the other, I would say for some specific components for technologies that did not exist when the regulations were initially envisaged, those need to be developed. Either the components themselves to those new levels of, I would say, high voltages or new applications of those technologies, or to even to some regulations that do not even exist yet.
Mm-hmm. Okay, thank you. And Sebastian, do you have any experience on that question?
On the previous question?
Yeah.
First of all, I would see the two different parts maybe in different subsystems or systems. Mm-hmm. So one is very much engine. Mm-hmm. What we are talking about when we replace a turbine, mm-hmm. and it's controlled by an electric engine or a combination of electric engines. I can tell that there are quite a few players out there who have the ambition to, and I think also the capability in aviation to develop electric engines. Mm-hmm. So names that were already discussed today. So I think that falls into their parameter. That is clearly possible, I would say, and their plan. It is not necessarily our plan as Vidiian, and the other part of it would fall into the battery, which is very much the battery management system. Mm-hmm. This part I would see very much solution specific, and what I can tell for us is it is very much a part of our what we consider our core IP, mm-hmm. integrating, building up the battery ourselves, building the software and the hardware for the battery control and the thermal management of the battery ourselves. That includes the hardware and the software to the required DAL levels.
Okay, thank you. And Roberto, already you mentioned the motorbike engine.
Yes, but regarding the management of battery and thermal runway and other problem, today we are following what is available for VTOL, mm-hmm. in terms of special condition and Mach 3, mm-hmm. that has been published recently. But we are confident that in a very few time there will be some more specific on CS23 for CS23 application.
Okay, thank you. Okay, then the top question here. The FAA has drafted the AC for Joby. Does the EASA foresee program-specific special conditions before more generic regulations are issued? Whether you can say anything.
I think, David, it's more related to the aircraft.
Yes, David.
Yes, David Solar, head of General Aviation and VTOL. So actually, the backbone of all eVTOL is the special condition VTOL with means of compliance. Obviously, after we are digging with each specific design. So actually, the third basis and especially the means of compliance are tailored to each applicant when necessary and when the design is not widespread, I would say. So it's not the same approach as the FAA. By the way, if you look at Joby and Archer, they are very similar. So you may wonder if it's generic or not. But we have a generic part which is fully adaptable. Special condition is a special condition. It can change at any time, depending on the design, depending on the evolution of the industry. Means of compliance we have generic for guidance to industry. And it was a request because it was at the very beginning very blurry, nothing was available, so at least to put something on the table that can be discussed. And when it is down to very, very specific detailed design to each and every project, we are obviously dealing then on a bilateral basis with the applicants.
Okay, thank you, David. Then is simplification planned for the release of flight tests with new technologies?
We hope so.
Well, what I would say, I mean, it's quite a complex area. Just to say, I mean, normally for experimental types, the responsibility lies with the national authorities, and naturally, then it's down to them. If it's more for development of a certification project, then it lies within EASA. So today it's quite a mixed field. What we're doing, though, for example, is we're trying to learn within EASA at least where we have seen new technology such as hydrogen aircraft flying, trying to contact the national authorities to try and better understand what they did in order to allow this, so that when we have some cases naturally that fall under EASA, and we will also look at this, and we will look at being as pragmatic as we can. Ultimately, safety is the number one thing that goes along with these. But I can't say that there is it planned? No, it's something. But for sure, it's something we look at and see how we can address that going forward. Okay, if we go to the next question, and this one is therefore Roberto by the looks of it. How is it planned by Voltero to control subcontracted development and certification of the HPMU for the Casio? Very specific question for you there.
Oh, yes, first of all, we are, as DOA ongoing, we have put in place some the procedures for management of development of design, and also for the management of subcontractors, starting from assessment, initial assessment, and then definition of the statement of work with subcontractor. So we are starting by defining an initial technical specification for our needs, in particular for the HPMU. And then we have started with support of the technicians, the quality manager, but also with the program management, the selection of a list of potential subcontractors. And we are moving in accordance to our in-progress procedures for DOA for qualification of the subcontractor. Mainly, our approach is not to delegate the compliance verification to the subcontractor, but to keep it in-house with our inspector CVE that are being presented for our DOE.
Okay, thank you. Then the next question down, so question to industry about TRL for battery technology views and forecasts you could share. Is there a ceiling for energy density? And maybe I'll go to Sebastian first on this one.
It may be easier to answer the question from the end. What is available on the market when it comes to the battery? There is, of course, a huge variety of companies that provide batteries and do research and technology and also production on batteries. I think what is a wise way at the moment is taking qualified products. There are no, so far, at least that I knew, specifically aviation qualified batteries available. However, in the automotive sector, there is, of course, a large variety of products deployed and produced in really high volumes, so to scale. We are also following the same approach. We are taking these battery cells and integrating these very battery cells, not starting on the level of building new batteries. And I think this is something that can bring you quite rapidly to a larger, higher TRL. In our case, we have planned to achieve TRL 5, 6 within the next year, which is really representative lab environment. And I think when it comes to the ceiling for the energy density, I mean, an important answer or question would be, what is the starting point? So at which energy densities can you have a meaningful mission? I believe it very much obviously depends on the aircraft configuration. In our case, a good starting point is slightly above 300 watt-hours per kilogram on a cell level, which reduces a little bit with the integration factor. And obviously, I see a ceiling very much dependent on the chemistry. So lithium-ion batteries, we all know, I think this is not a big debate here, are going to make an increase, but not a leap in terms of multiplying by 10, maybe. So we see ourselves maybe multiplying by a few hundred watt-hours, but that's going to be the end of the chemistry.
Thank you. And Roberto?
From our perspective as end user of battery, we look what the status of the market provide us. Now we have in around 200 kilowatt per kilogram, more or less. And this is the problem we are monitoring in order to understand in perspective. Someone is thinking to put this target to 400, but the time is still long, so we have to cook our eggs in a very few time.
Okay, thank you. And Eduardo, from your position?
Yeah, I'll just adding a little bit on what Sebastian and Roberto have mentioned. One of the aspects that I think from our side needs to be taken into a lot of consideration and be better understood is when we talk about it at the cell level and at the pack level. And that brings a lot into those crashworthiness and flammability and fire protection considerations that have been mentioned by the other participants as well, because whatever you have at the cell level, until we have a better understanding as an industry of what is going to be required in terms of those safety considerations and crashworthiness of the batteries, what we're going to have at the pack level itself, that's going to change a lot.
Okay, okay. No, understood. Thank you. Then if we move on to the next one, Hedris, I don't know, can you say something about the HPS webinar quickly, or is that something we need to take and send a message to those that...
So normally there will be a message that will be sent to all already registered participants, and basically there is no need to register again, because the registration is allowing to have the email of the participants, and therefore a WebEx link will be sent to all already registered participants. So please, if you have already your name on the list, don't register again.
Okay, thank you. And then now we're literally coming to the end. I'm just trying to see. I don't think we have anybody here on drones to speak to. Oh, David. Okay, David, if you can take this one, and then I think we need to close this session.
Yes, so actually the drones, you have quite a significant regulatory framework, which is on the specific category. We have the light UAS special condition, which is addressing that, and obviously cargo drones could be in this category. On the certified category, we are actively working on it. And if you take a look at the also eVTOL part, you have 0 passenger, so cargo could be also integrated. But so far on the certified drone, we are working actively on developing a similar special condition and the light UAS one.
Okay, and then as there's a question there on the pre-application, I can just speak very quickly that normally we sign a pre-application contract with a company, and if that company wants to work jointly with EASA and the FAA, and the FAA agrees, then we're very open. But normally for the pre-application contracts, there is a certain amount of flexibility how we work, and a lot of it will depend on how the applicant in question wants to work for those applications. Okay, so we're at the end of this session. We'll go to the coffee break next. After the coffee break, we have the session on hydrogen. Just because I didn't speak to everybody yet, but those presenting in hydrogen, please, can you be here 10 minutes before the end to get wired up? Other than that, I would like to say thank you to all the participants here. It was an extremely interesting session, so thank you very much.